Actually, before you even think about starting to do any wiring, you should put yourself in the mood. You need to be at the same time relaxed and alert. And for that, traditionally, the best way to do it is to pick up a cup of coffee or cup of tea or both. Please don't try with scotch. You may be surprised that by doing it, you are going to carry on mistake after mistake, so may not be the best idea. So stick with the coffee or tea. Okay. Now we have an empty breadboard here, and the only things I linked to it are two wires, a red and a black. These ones are going to carry on the 5 volts. The bar in the top is exactly for that purpose, to carry on the 5 volts, the ground and the positive, everywhere, to give access to the little breadboard sections. Okay? So I'm going to plug any wire here. So from here, I'm going to pick up a couple of wires, like this one, to the red line, another one from the same to the red line here, and another one from the same to the red line here, and just to make sure, another one from here to the red line here. So this way I'm going to have access to the positive from anywhere. Additionally, I'm going to connect the ground. So the ground is going to be from the top line on the blue. So on the blue, from here, on the blue, and here, another one more. So this way I have access from anywhere on my little sections to carry on the power. Then I'm going to place the components. The components are going to be placed like this. Let's say, remember the notch is right here in the top. I put labels on the packages for you to easily identify which is which. These are going to be the 2 shift registers, and then we're going to have the 2 decoders and the inverter between. Yeah, I'm checking the notch with my fingernail. If the pins are bent, you have to be very careful, because otherwise you can do mistakes. So I have 2 decoders and the inverter between, and then I'm going to place the 2 digits this can be very nicely aligned. See, like this. And for later use, I'm going to place here the 2 Texas Instrument hexadecimal digits, and to not forget our breakout board with the PS2 connector right here. Okay, very well. So now what's missing, we need to connect some resistors, and for the decimal points I should have already prepared right here 2 additional resistors the same size as the other ones. So the components are placed. Okay. This one being said, we pass to do the wiring. The first kind of wire we have to connect for any kind of project like this is to connect the power. So I pick up these black wires. We have to put a ground on all the 5 packages here and to the PS2 connector. For the PS2 connector is the pin number 3, which is this one here from the top. Again, don't worry about it. I'm going to put a diagram online. And the packages are user-friendly. All the 5 packages are user-friendly. So the ground is the last pin on the bottom left, right here, and here, and here, one more, and we tie all these to the closest ground line. This. So all of them, they have a ground. Very well. Next, we're going to plug the VCC, which is 5 volts for our project. Because it's again a user-friendly package, the positive or the VCC is the last pin in the top right. So we plug them all in the closest red line. So like this, they are going to be easily energized, because in a lot of projects the people start to do the logic of the wiring and they forget about the power. So now our problem is solved. And what we also have to do for our 7-segment displays, because these are common anodes, the pins number 3 and 8 are going to be related also to the positive. So just to make sure we're going to have a good connection, I'm going to plug both pins 3 and 8. So I plugged the number 8, and now I plug the 3 to the closest line, closest positive line. So now everything is energized. Okay. Then we focus on the control terminals. For the 2 shift registers, 74-164, we have 2 data inputs, data input A and B. We only need to use one data input, the A, and the B, because it's not in use, we're going to connect it to plus 5 volts together with the clear or the reset, because we also don't need it. And because we connect them to plus 5, I'm going to still use some red wires. The input B is the pin number 2, and the clear is the pin number 9. So for both, it's going to be the same story, 2 and 9. And from here, you go to the closest positive line, closest positive line, job done. So these were pins we had to connect to the positive 5. Now the clock. The clock is on the pin 8. So we're going to have a wire connecting the pin 8 for both of them together, just like this. And the clocks are coming from where? They're actually coming from the clock of the keyboard, excepting it has to be reversed. So we're going to have a wire between any of these pin 8 to the output 2 of the inverter, where the input 1 of the inverter is going to the clock, which is the pin 5 of the PS2 socket. For the clock, if we take a look, is the pin 5 over here, and it's gonna come to any of the pins 8 of the two packages together. Okay. Oh, sorry for that. It's going on the pin 1 of the inverter because the clock is inverted. Okay, so far so good. We prevented the first mistake. Now we finished with the clock, and now because I touched the inverters, let's check all the wiring for the inverters. I connected only one inverter at this point, the pins 1 and 2. Now let's find out the pins 3 and 4. Pin 3 is related to the output B of the top shift register. So I'm going to pick up a wire, and the pin 3 of the inverter, this one, is going to be connected to the pin 4. Here it is, of the top shift register, as the output pin 4 of the inverter goes straight forward to the resistor controlling the decimal point. So this is actually going to be the parity bit of the shift register, and this is why we want to monitor it on the decimal point. So for that, we're just going to need a wire from the pin 4 of the inverter, a wire from the pin 4 of the inverter over here to the resistor right here in the top, and to make sure the other end of the resistor goes to the pin 5 of the top display. So because I used a orange wire, I'm going to use the same over here. So it goes exactly to the pin 5 of the top display. So this way I have it under control. Now I notice also that the second decimal point for the second digit has one leg connected through the resistor to the ground, and the other leg of the resistor goes to the decimal point. So this one is just equivalent to power on. Okay, so for this I'm gonna pick up from the second resistor a wire to any ground, like here, and the other leg of the resistor, is going to be connected to the pin 5 of the second digit. So this way I've got rid of the two resistors right here in the bottom and the decimal points of the displays. So far so good. Next, I'm focusing to not forget on some control pins of the two decoders, the pins 3, 4 and 5. They are all control terminals, and because we don't need to use them, but at the same time we cannot leave them floating into the air, we're going to connect them to the closest 5 volts. Okay? So for the decoder, the pin 3, 4 and 5 are going to come to the closest positive line, like here, here and here. So we do the same for the second decoder, the pins 3, 4 and 5, they all go to the closest positive line, like this. So this way we've got rid of some control terminals. We don't have to think about that anymore. Next, the next thing to think about, since we have the data inputs connected, the reset connected, the clocks connected, we now focus on the outputs of the two shift registers to the inputs of the decoders. So for that, we're going to use 4 distinctive colors to prevent confusion. So then we're going to have the output 5 of the top shift register is going to go to the input 6 of the decoder. So the number 5 is right here, and it's going to go again to the pin 6, which is right here, of the decoder. Next, the pin 6 of the shift register, the pin 6 of the shift register right here, is going straight forward to the pin 2 of the decoder over here. The pin 10 of the shift register, let me see, 8, 9, 10. Okay, it goes to the pin 1 of the decoder, okay, which is the input bit, and the pin 11 of the decoder, sorry, the pin 11 of the shift register goes to the input A, which is the pin 7 of our decoder. Yeah, it was an empty spot right here. So we connected all the 4 inputs of the decoder to 4 outputs of the shift register. Now there are 2 additional outputs we have to use from the top shift register, which are going to be related to the lower part of the diagram. So the pin 12, which is the output G of the shift register, if I pick up a wire from here, is gonna go pin 13. Okay, this one not 13, should be 12. Okay, so 12 is gonna go directly to the input 6 of the second decoder. Just need a longer wire to the input 6 of the second decoder. Okay, so this was the number 12. Okay, this is done. And now 13, which is the last output of the top shift register, is gonna go into places. It's going to become, let me just plug it. Okay, 13 is going to become the serial input of the next shift register, so the pin 1. And from there is going to go to the input C, which is pin 2 of the decoder. So to the input C, which is the pin 2 of the decoder, right here in the bottom. So this one is done. So now we connected already 2 inputs of the second decoder, and the other 2 inputs are going to come from the second shift register. So from the second shift register, the pin 3 is gonna go to the pin 1. So the pin 3 over here is gonna go to the pin 1 of the decoder. Yeah, it's an empty spot. And pin 4 of the decoder, sorry, pin 4 of the second shift register, pin 4 of the second shift register, it has to go to the pin 7, the remaining spot on the second decoder. So far so good. So we finished to connect all the wiring around the shift registers to the inputs of the decoders. At the same time, we connected the controls of the decoders. So now we focus on what's the easier part, the connections between the decoder to the resistors, and then to transfer these to the digits. Okay. So for this, I prepare here a bunch of wires for that purpose. So by respecting a kind of color code, it's gonna be the same color coming from the decoder to the resistor as it is from the resistor to the digit. So this way I can keep a certain order in case I need to do troubleshooting later on. Okay. So for my segment A, the segment A, which is connected on the pin 7, if I start with the one in the bottom here, the pin 7 is over here, and this is the segment A. And segment A, I'm going to connect it right here. The B is the pin 6. So I'm going to use another color. I'm going to use this one. B is going to be the next in the top of A. And then I'm looking for C, which is the number 4. The number 4 is right here. Is going to be the next resistor. And then, after I connected the C, is going to be D, and D is the number 4. Okay. If you take a look on the display, we connected C on the 4. Sorry, D is on the 2. D is on the 2, right here. So A, B, C, D. Now we look for E, which is the number 1. Number 1, which is over here, is in the top of the next one. Now we look for F, and F is on the pin 9. F is on the pin 9. Okay. So here there is a little mistake. These wires should have been connected not in the top resistor, but in the bottom one. I'm going to finish to make the connections, and then we're going to shift it in the bottom. So the last one is the G, which is the 10. It was just the remaining spot over here. So now we just shift them one by one to correct the mistake. It's very easy to do mistakes even if your coffee was good. But once we identify, it's also easy to correct them. And luckily, that's a very easy way to correct the mistake. That's it, job done. Okay? So, we connected the bottom display to the resistors. So guess what? We're going to do exactly the same wiring for the top one. So this is why when respecting a kind of color code is so easy. Okay? So if we just start from here, from the top, it was the pin 10. Here in the top. Okay. So then it was the orange wire. There's the orange wire on the pin 9 connected to the next. And then it was let me see to make sure we're in the same position. The two of them are here. Then we're looking for the white wire, okay, on the white wire over here. And the white was going on the pin 1. And then we were looking for the fourth one is the black wire. So the fourth one was the black one, and it was going to the pin 2. There is a spot right here, pin 2. Then it was a blue wire. Then it was a blue wire here, and the blue was going on the pin 4. Yeah, there is an empty spot right here, pin 4. And then we had a green wire, and the green was going to the pin 7. And finally, we should have, let me see, we should have here the pin 6. What happened to the pin 6? The pin 6. Okay. So the green was actually in the bottom. So here was the pin 7. Yeah, it was good. So now, let me see if the connections are right. Here, the top one should be, okay, these two wires are reversed. I can see it now. So the top one should be the pin 7, and the bottom one should be the pin 9. Okay, so the top one is the pin 9, and the bottom one is the pin 7. Okay, so now let's So the green is the 7, and it goes right here, and 6 is the yellow, and it goes over here. Very good. We continue. So we finish the wires between the resistors and the digits. So now we're going to place the wires between the other legs of the resistors to the decoder outputs. For this, we have here a second bunch of wires with the same colors. And why is this going to be easier? Because since we respect the kind of color code, and it goes from the bottom A, B, C, D, E, F, G, is going to be the same on the other side of the resistors. So then, I'm going to plug the same colors, literally. It's a green, then I have a yellow, then I have a blue, then I have a black, and then I have a white, and then I have an orange, and the last one is a red. Same in the bottom. I'm starting from the top. I have a red, then I have a orange right here, then I have a yellow, and then I have a, oh sorry, I don't have a yellow, I have a white. Okay, after this white I have a black, then I have a blue, then I have a yellow, and the last one should be the green, because that's all I have in my hand. That's it. So now, it doesn't matter, let's say I'm starting with the last ones right here in the bottom, okay? So I know that the one in the bottom, the green, is coming from the segment A. Where is the segment A connected on the decoder is the output QA, because the letters of the outputs QA, QB, QC, QD, E, F, and G are the same letters actually as the letters for the segments. Okay, so this is the pin 13. So 6, 5, 4, 3, pin 13. Next, B. B is a yellow wire, is the pin 12. And C is the pin 11. Then C is the pin 11, right here. And then D is the pin 10. And then D is the pin 10. And E is the pin 9. F is the pin 15. F is the pin 15. And G is the pin 14. So the last one here is the pin 14. It's going to be the same in the top. So let's start again. We start from A. A is the pin 13. This one is 6, 5, 4, 3, pin 13. Okay. B is the next, is the pin 12. C next is the pin 11. Okay, D is the pin 10. E is the pin 9. F is the pin 15, and G is the pin 14. So we finished the wires for the decoders. Now we have to return back to our mini DIN or PS2 connector, because at the beginning of the diagram we only connected the ground. So now it's time to connect the positive, which is right in the top of it. Don't have to forget that, to any positive line, and the input, which is the data, and this one is coming right here on the pin 1. This one has to go on the pin 1, the serial input A of our top shift register. Okay, good.